it's been over a weekend, right? So some of the content you may already forget. So let's have a little bit of review of what we covered last time, right? So last class, we learned about different types of relationships, right? We have three categories: one-to-one, one-to-many, and many-to-many. So the way to tell which relationship type that is, we look at the maximum value of the multiplicities, right? So that's how we tell apart different types of relationship, and we utilize this Lucy chart to do the case study practice. So if you can still find your chart, now it's time to log into this Lucy chart and find out the diagram you did, because later in practice 2, we're going to continue with our case study. So this is what I have, and I think we have the same diagram. If not, please let me know. So I believe last time we say that we identified 3 classes, right? Patients, patient visits or bills, and types of tests. So last time we started by having bills as a separate class, right? And then we ended up merging these 2 classes because they have a one-to-one relationship. So for simplicity, we can just merge these 2 to save one table, right? So that's I believe that's what we discussed last time. So have this ready because later we're gonna use it. And we introduced what is primary key, right? The primary key is or a combination of attributes that can uniquely identify each instance. So we and also the primary key cannot be null, and it cannot change over time. So we went through these different questions. The first, can we use social security number as primary key? In many cases, the answer is no, because some people may not have SSN. For example, international students may not have social security numbers, right? So that's so then the social security number will violate the second criteria, which says the primary key cannot be null. And second, can we use people's names as primary key? The answer is also no, because the names can be duplicated, right? And people's names may change over time, right? For example, getting married, or you change your first name or last name. And third, can you use phone numbers as primary key? The answer is also no, because it may change over time. People may change their phone numbers. And lastly, this basically says, yes, we can use serial numbers as a primary key. And actually, this is best practice for generating primary keys. For example, Ruggers. Ruggers generates this RUID, right, which is a unique 6-digit number that can uniquely represent each one of us. And this primary key can be managed, like this RUID can be managed by Ruggers so that it cannot be null and it cannot change over time. For example, if you are at Ruggers, you used to be a student and now you are a TA, like teaching assistant, and so forth. Even though your role may change within Ruggers, your ID is still the same, right? So Ruggers can maintain the primary keys in a way that these criteria will be met. So the best practice is to assign these serial numbers to represent each instance. So now this class, we're going to cover foreign key, and we're going to learn where to post the foreign keys. Okay, so primary key, as we said, is an attribute or a combination of attributes that uniquely represent each instance. Then foreign key can be determined as an attribute that is a link between 2 tables. Okay, so here foreign key is just a link between 2 tables. Now, to illustrate what is a foreign key, let's look at this relationship between person and auto. Like we said that, so first of all, I want to ask someone, is person to auto one to, oh, sorry, I don't think this can be asked, right? Because it's already in the title, it is a one-to-many relationship. So basically, this says that one person can own 0 or multiple cars, right? But a car can be owned by one and only one person. So this is a one-to-many relationship. So if we were to map each class into a table, this may be what the table will look like. So let me first delete this auto ID here. Okay, so let's say we can use a person table to represent the class person, and this auto table to represent the class auto. So in the person table, we have to use a primary key to uniquely identify each person, right? So that can be this field or attribute called person ID. Let's say this is just some, serial numbers to identify each person. And similarly, on the auto table, we need to have a primary key to identify each car. Let's say that's auto ID, right? That is to say, we now can pick the primary keys for each table. And now, because we say that from this one-to-many relationship, we know that each car has to be owned by one and only one person, right? That is to say, in this auto table, there has to be a field called person, or something that says, this car belongs to someone, right? Let's say this is the auto person ID. So that is to say here, this person ID is a foreign key in auto table, because the person ID establishes the link between the person table and the auto table. Okay, does this make sense? So in this case, we are posting the foreign key in the auto table. And here, the person ID is a primary key for the person table, and it is a foreign key in the auto table, linking these two tables together. Okay. And now, so any questions here? Why can't we post a foreign key on the person table? Right? Why the foreign key has to be in the auto table? That's actually a very good question. So now let me do this little revision here. So now I am doing some, let's say, on the person table, hypothetically, let's say we create an attribute or a column called auto ID. Okay, so if that's the case, whether that will work. Okay, so now the reason why we have to post the foreign key on this auto table, which has this meaning as its multiplicity, is due to how a relational database is structured. Okay, so this restriction is that for one row in a column, you can only have one value. So let me show you an example. So let's say I have some table here, right? And let's see, how can I do this? So say, let me see, let's create a table called person. Okay, so I'm just doing this here. Let's say I have a table called person, and I will just change the name of this sheet into person to indicate that this is a person table. And we're going to learn more about a database next chapter, but this is just to illustrate. Okay, so in this person table, let's say we have an ID for each person, and let's say name, and then hypothetically, let's say auto ID, okay, to show that this person is owning some cars. So let's say first, a person may have ID of 1, 2, 3, and name, let's say it's me, Abby. Okay, so now here is the problem. So let's say if I have one car, that's fine. Let's say I have an auto ID of 345. This has no problem at all. The problem generates when one person has multiple cars, because that way, hypothetically, right, you may put something like, okay, Abby has 4, 5, 6 as a car, and maybe 5, 6, 7 it's another car, maybe 9, 8, 7 is another car. So this kind of data structure is not supported in a relational database. So that is to say, on the person side, right? Because one person may own up to multiple cars. This situation is not permitted under this relational database. Whereas if you look at this auto, you like, for example, in this auto table, let's say auto ID, you have 1, 2, 3, its model, and then you will have a person ID. So in this case, because we say each car can be owned by one and only one person, then this value here has to be something, right? And this something has to be unique. So that is to say you won't have the situation where each car can be simultaneously owned by someone. That's not possible. So due to this feature of a relational database, the linkage, so that is to say on the person table, we cannot have a column called auto ID because it doesn't support this multiple value situation. So this column has to go away. We have to delete that. Whereas on the auto table, we are able to keep a column called person ID to indicate who does each car belong to, right? So that's why we end up having just this table of person without the auto ID, whereas on the auto table, we can maintain person ID. So then in this case, the person ID is becoming a linkage between the person and auto table, right? And that's why here we can only post the foreign key on the auto table, not person table. Does that make sense? Okay, yeah. So here we actually have a rule, right? So in any one-to-many relationship, the foreign key is always posted on the many side of the association. Right? For example, here we have a one-to-many relationship. The foreign key is always on the many side. Here it is the auto side. Okay. With that in mind, okay, another thing you might I want to mention is that the foreign key in one table must be a primary key of the table that it is linking to. Okay, so for example, here, the foreign key is person ID, and person ID has to be a primary key of a person table, of the table that this foreign key is linking to. Okay, now with that in mind, now I want to ask, where would you post the foreign key, on the A side or the B side? A, right, because that's the many side, right? Okay, okay, that's a second example. Good. B, right, because that's the many side. B, also B, yeah. So that's very simple, okay? So just to emphasize, currently we're looking at one-to-many relationship, right? And the rule is that, well, no matter what the name are for the classes, we always post a foreign key on the many side. Now let's look at one-to-one relationships. So for one-to-one relationship, this should be very intuitive. Okay, so if the multiplicities are the same on both classes, for example, the first and second items on my slide, right, because they have the same 0 or 1 on A and 0 or 1 on B, or they have the same 1 or 1 on both sides. If that's the case, it doesn't matter where you post the foreign key because it's the same. However, it matters when you have different, like for example, A has 1 or 1 and B has 0 or 1. If that's the case, we post the foreign key on the class that has minimum of 0 multiplicity. So in this case, we would post the foreign key on B, and in the fourth item, you would post the foreign key on A. So let me explain using an example. So like a typical one-to-one relationship is the social security number to person. So let's say a person may or may not have social security number, right? Let's say international students, they do not have social security number before they get paid, right? But if they have a social security number, that has to be one, right? That has to be a unique one. So then on the SSN side, it has 0 or multiple. But if there is a SSN, if there is a number, it has to belong to someone. So that's why on the person side, it is one and only one. So then following this logic, if we were to use tables to represent the classes, so let's say we have a table called SSN, then let's say, in this situation, you are able to use SSN as the primary key, right? Because, in this world, let's say if anything can be listed on this table, then there must be a value for SSN, right? So in this case, you are able to use SSN as primary key. Okay, and then we said that each SSN has to belong to someone. Then you must have a column called person ID, right? And this value cannot be now this person ID. It has to belong to someone. But on the person side, right? Like here, yes, this is why the person ID is acting as the link. So like technically you are also able to create a SSN number column here, but in this case, that column might be unnecessary given that you already are able to establish the link via this foreign key. So there's no need to include an additional SSN column here. So in this case, the best practice is to put the foreign key on the side with minimum 0 class. Okay. Does that make sense? Okay. So now one-to-many, one-to-one, now it's clear to us. The problem is the many-to-many relationship. Okay. So we said that let's say for this example, right? Auto to dealer. So this is saying that for each car, it can be serviced by multiple dealers. And each dealer can provide service to multiple cars. So if we think about this example regarding like why we cannot, include a column that may contain multiple values, then like we can, let me see if I can create a table. Okay, dealer, right? So that is to say, following the same logic, we cannot place any foreign keys on these classes that have like multiple as its or many as its multiplicity. So I can illustrate with an example later. But to resolve this problem, the way to resolve this, like many-to-many, unable to placing any foreign key on this many-to-many relationship, is that let's create a linking table to convert this many-to-many relationship to one-to-many relationships. So the way to do that is that we create a table that has the combination of information from the tables that we are connecting. For example, to create a linking table for auto and dealer, we can create a different table, let's call it auto dealer or auto service, which essentially contain, maybe I should use this, the primary keys of auto table and for a dealer table. The combination of the two form the primary key for the auto service table. I think I'm losing you, so let me just take it slowly. So this table can better describe what I mean. So let's say we have a table, right, called auto to represent the class auto. And the primary key, for example, can be auto ID, right, for auto table. And then for the dealer, we can have a table called dealer table, right? And then the primary key can be dealer ID. Okay. Now the linking table, which is called auto service, or you can call it service by, whatever. In this table, we're going to have both auto ID and the dealer ID. We pull these primary keys together. And so that the combination of the two will generate the primary key for this table. So for example, let's say auto, let's say car number 1 is serviced by dealer number A. Then that will be reflected in this linking table as just, let's say 1-A, something like that. It's that combination. to show that, this car is serviced by that dealer. So it's essentially combining the information from the two tables. So in this case, here you would have the combination of two attributes as a primary key for this linking table. And then for each attribute, it's going to be simultaneously a foreign key in this linking table and a primary key from the original table where it comes from. So for example, the auto ID will be simultaneously a foreign key in this linking table and a primary key in this original auto table. Okay. Any questions or confusion for service by? Oh, yeah. So here, I should have showed you the rectangle. So here, the primary key is the combination of auto ID and dealer ID. So let me illustrate using an example, right? So let's say we have a table called auto ID, right? The one that I showed. And then auto ID, this one is the primary key. And then for dealer, this is dealer ID. Maybe you have other attributes such as address, so on and so forth. And then for this linking table, I'm just naming it as a link, or you can call it a service by. So you would have both auto ID and dealer ID, right? So let's say in this example, this car number 1 has been serviced by dealers 54 and 87, okay? So hypothetically, you can generate a primary key that is the combination of the two attributes. So let's say you can generate something like 1-54 or 1-87 as like a primary key for these, right? But you don't have to generate this separately. You can just say, the combination of auto ID and dealer ID are serving as the primary key. So whenever we have a many-to-many relationship, we have to convert it into one-to-many relationships because we're going to need this in our relational database creation. So without this linking table, it is impossible to link these two tables in a database. Although conceptually, we can map this many-to-many relationship using this UML diagram, right? Like what is shown here. However, we have to convert this many-to-many into one-to-many relationships for us to implement it in a real database. So that's why we have to do this conversion. So to your answer, that's yes. We are going to do an exercise after to better understand this conversion. Oh, and I forgot to answer your next and related question. So whenever you create a linking table, the primary key of the original table becomes the foreign key in this linking table. But when combined, these primary keys originally in those in the tables that we are trying to connect, combined, they become a primary key for this new table. Does that answer your question? So that's why in the textbook, there is actually a summary of where to post the foreign key. But I break it down into different scenarios to you, right? For example, in one-to-many, you always post the foreign key on the many side, and one-to-one, it depends on whether it has a 0 as minimum. For many-to-many, we have to create a linking table, right? So you can also refer to this summary table. But I think this way of, separating them into one-to-one, one-to-many, that's more clear. Okay, so now let's look at the practice number 2. So practice number 2 basically says, like if we go back to the practice 1 exercise, right? So there is a many-to-many relationship that is between the patient visits and also the types of visits. Now I want you to create a linking table to convert this many-to-many relationship into one-to-many relationships. And you can use the example of this auto service as a guide. Okay, so when you create this linking table, you can name it in any way you want, as long as it makes sense. What test each patient gets? Okay, So because here it seems that you are talking about the number, which is not, I don't think that's what this linking table will include. So to me, this is more of a patient versus and test combination. For example, in this visit, Abby get a blood test, that kind of information to link Abby's visit with the type of test that I get. So if I were you, I may put something like just say patient tests, because it shows both the patient visited and get a test. So patient test, or you can say patient visit and test, something like that. This is more descriptive actually. Patient visit and test table. And now let's look at the multiplicity here. So for each, let's first look at this one highlighted here. For each patient visit, what's the minimum linkage here? Because for each patient visit, the patient may not get any test, right? So yes, the minimum here is 0. What about the maximum? For each patient visit, this visit can, for example, I pay an annual physical visit. In that annual physical, I can get multiple types of tests, right? So do you agree that here we should do a many as the upper bound? Okay. So here we are settled on this, right? Let me just put it in a different color. Okay, so let's look at whether this makes sense. Okay, so for each patient and the test combination, let's say Abby's visit on Monday and she got a blood test. Let's say that's an entry, and that has to tie to my visit on Monday. Is that right? So here the minimum has to be 1. I saw someone did a 0 and or 1. I think you did a 0 or 1. Like here, actually, this is also related to the feature of being a primary key. So I'm just using this auto dealer linking table as an example. So let's say for this auto dealer linking table, right, the combination of auto ID and dealer ID forms a primary key. So this is our hypothetical primary key. In this case, both features need to be done now because that's the primary key. Otherwise, if you have one value missing, for example, let's say for car number 2, say it is never being serviced by dealer ID number 80. So you say, okay, maybe this is missing. But then if that's the case, this entry would never be included in this linking table, right? So then you wouldn't have that chance of having any of the attributes as now. So if there is an instance in this linking table, it has to link to an item in either of the original tables. So that is to say, this patient visit, right? If there is a patient visit and test, it has to be linked to a patient visit entry there. And it has to be a 1 and only 1 entry. Does that make sense? Okay. Similarly to the to this side, one patient visit test has to be tied to here. What should be the value? Counting. One patient visit and test entry can be tied to how many type of tests? Let's say Abby's visit on Monday and she performed a blood test. The example I provided here, right? Let's say a combination of auto service. Each entry, like for example here, this link to 1 and only 1 auto or car, and it links to 1 and only 1 dealer, right? That's why applying the same logic here, then each entry of this patient visit and test, it goes back to only one type of test. And what should be the multiplicity here? One type of test, let's say blood test, can be associated with how many patient visit and test combinations. So you can use some examples here, right? Like blood tests can be applied to Abby's visits, right? So here the the maximum can be many. And we discussed last time that for certain type of tests, let's say a rare disease, ABCD virus test, that type of test may not apply to any patient at all. So here we discussed last time that the minimum can be 0, right? So here we converted that many-to-many relationship to one-to-many relationships. And actually, there is a little trick here. If I have the original chart back, let me show you how to quickly do this conversion. So originally we had this patient visits and directly tied to types of visits, types of tests, right? So that's what we had before. And change this. So this was what we had, right? Like patient visit to types of tests, originally 0, many-to-many, represented by having this 0 multiple versus 0 to multiple. So when we do a linking table like this, we are going to maintain the original many-to-many relationship. For example, here we have 0 to multiple versus 0 to multiple. We're going to maintain that on both sides of the linking table, right? So here you see that on both sides of your linking table, it maintains the 0 to multiple multiplicities. Whereas on the other end of that original table, that's going to be 1 and only 1. And similarly, if you look at the example provided on the slides, so here, originally the auto to dealer, it is 1 and many versus 1 and many. And when we convert this to one-to-many relationship, this 1 and many, 1 versus 1 many are maintained on both sides of this linking table. And on the other end, it's always 1 and only 1. So that's a quick way to do a linking table. Is this confusing or this is difficult to understand? I can repeat. Yeah. So this actually can be inferred as we show here, right? Because here we have a very unique situation where the auto ID and dealer ID separately, they are foreign keys in this table. But when combined, they are the primary key of this linking table. And by definition, the primary key cannot be null. That is to say, either auto ID or dealer ID has to have a value. And if that's true, that a value has to be linked to 1 and only 1 instance in the table where it is coming from. So that's why it's always 1 and only 1 on the other end of this relationship. And we are to maintain the original multiplicity on both sides of the linking table. Okay, move ahead. And by the way, this conversion is very important as we move to the next chapter because we're gonna need linking tables if there is a many-to-many relationship to implement any databases. Okay, so this is very, very important concept, but we're going to review this as we move along, okay? So for the rest of the 10 minutes, I want to talk about other UML relationship notation. So remember, I emphasized a lot as to, about like when we establish the relationship, right? We cannot include arrows to represent like a generic association. This is because when we add arrows, it will mean a different types of relationship. And for this class, we just need to understand that there are different ways to represent these different relationships, but you don't need to learn how to use it. So first, what if we add an arrow on this line, okay? So that will mean something called a generalization. So that means, let's say you have a large category called cars, right, or auto, but then you have specific categories of cars. Let's say you have sports car, sedan, SUV, and many others. So for these subcategories, first of all, these are all cars, right? So they must have some attributes like engine, number of tires, so on and so forth. However, each category of car may have their own specific characteristics, right? So if that's the case, you can use this generalization relationship to say, for the sports car, because it's a car, right? So I don't have to create columns like number of engines, number of cars. Just refer to the table autos because that already has the information. So in the table of the sports car, I can only include specific attributes related to sports car. So that's a way to simplify the modeling process. So that's called generalization. And if you use this kind of shape, it's a little bit like the gateway, right? The diamond.